Hey guys, this video is going to talk to you about the volume of a cone and how to find it. But first, let's talk about what a cone is. If you remember, from a prism to a cylinder, they're basically the same thing. The special thing about a cylinder is that the two bases are circular, where in a prism, the bases are polygons. Okay, so the same idea applies from a pyramid to a cone. Okay, remember a pyramid is some sort of a polygon base that has triangular faces that come up to one point. Okay, same idea in a cone, except for the base shape is a circle, does come up to the point, and you can see from the side it looks like a triangle. The face itself, when you flatten it out, is not quite a triangle. You're going to see what it is in the next video, but it's definitely the same idea. It's a special case of the pyramid. Okay, so let's talk about volume. Okay, we already know from previous lessons that the volume of a prism is just the area of the base shape times the height. And remember, base and height have to be perpendicular to each other. The volume of a cylinder is the same thing because basically a cylinder and a prism are the same, but the base shape, again, is a circle. So the base area of the base is pi r squared, and then we still have times the height. Mr. Carnes showed us in his cool videos that if you have the same base shape in a prism and a pyramid and the same height, okay, from top to bottom, the same height, that this pyramid is 1/3 the volume of this prism. Okay, so 1/3 base times height, or like some of you like to do, base times height divided by 3. Okay, those are the same. So let's use that same idea for the volume of a cone. A cone is really a special type of pyramid, okay? And the base shape is a circle. So we already know what to fill in here. We already know that the area of a circle is pi r squared. And we still need the height. And of course, if you're one of those people that likes to do all this work first and then divide by 3, that's completely fine, okay? So in your notes, this would be a good thing to write down. These are all volume formulas. We're going to do 2 examples today on how to find the volume of a cone, okay? And just like Mr. Carnes has reminded us, we're going to write down volume formula, okay? This is a cone, so this is the formula I'm going to be using today. And again, if you like this one over here, you can use that. So 1/3 pi r squared times the height, okay? Now remember, in a cone, just like in a pyramid, you have to pay attention to the difference between height and slant height, okay? Mr. Kleinhans did a nice job of showing us in his video what this height was. He used a pencil going through his pyramid, okay? So the height goes from the very tip top of the shape, the point, perpendicular to the base, okay? That's what the height is. The slant height is on the outside, and the radius, of course, is halfway across the circle on the base, okay? So in this case, they tell us that the diameter, or all the way across, is 20. So I need to find the radius. The radius is just that part. So that's half of 20, 10 inches, okay? The height, remember, is always perpendicular to the base shape, okay? So height is 25 inches. So all I have to do is plug this into my formula. Pi times radius squared times the height. Okay, and I'm going to throw that all in. And I'm getting approximately 2,618 inches. Now volume is how much stuff it takes to fill. Remember Mr. Carnes' video that showed that it took 3 of these, you had to fill this one up 3 times in order to make the volume of this. It's the same concept for a cone as compared to a cylinder. If I could fill up this cone 3 times, it would be the exact volume of the cylinder when their bases and their heights are exactly the same, okay? So, because it's filling, our units are cubic. Our second and final example for this video is find the volume here. And again, volume 1/3 pi r squared times the height. Okay, this time they gave us the radius, 2 feet. And then for the height, it's not 12. Okay, you can see 12 is on a slant, 12 is on the outside. That's good for surface area, it's not good for volume. We have to find the height here. And of course we see that that's a part of our right triangle. Okay, my model's falling apart a little bit, but it's a part of that right triangle. So I'm going to do 2 squared plus h squared equals 12 squared. Okay, I'm going to get 4 plus h squared equals 144. I'm going to subtract and get 140. So h is going to be the square root of 140. And I'm going to leave it like that because I want it to be as exact as possible till the very, very end. So 1/3 times pi times the radius squared times the height. Fill in the height. Okay, and if I want to know what that is, I'm going to just type it into my calculator. And I'm going to get approximately 50 feet cubed.